brownish color, but it actually has a reverse image of the picture on it. Okay, so let's do some science experiments underneath here. Again, you don't have to just stick with looking at flat things. You can experiment. So the next page actually has what pages? There you go. Chemical chemistry. So you're going to create a slide and you're going to do a chemical reaction underneath. I need scissors for me, please. For this one, you will actually need some scissors. If you don't have scissors handy, you can always use a plastic slide out of this box. But when I'm doing something I think might tear something up, I like to use transparency paper without breaking things. Thank you. Or you don't need to get scissors because I have another idea for you. That note card we used earlier, this one, let's just flip it around. So we use the other end of it, punch a hole in it just like you did before, just like that. But with this one, I want to make sure that the edges are pulled back. Okay, I'm going to punch another hole here. Same thing, and then the last hole over here. So now, I heard someone call this a business card slide because you can take someone's business card and if you're never going to look at it again, you just punch holes in it and use it for a microscope slide. So let me make sure that hole's fixed. Yeah. Flat, flat, flat. All right, take the tape like we did before. It's the only thing I don't like about Christmas. I like to wrap, but I don't like taking tape off, even when it's in that container with the cutter on it. All right, I'm pulling back enough so that I have multiples. And I'm going to pretend you don't have scissors, so I'm not going to use my scissors. All right, I'm going to cut it, snip. I'm going to cut this into more pieces. 1, 2. So I just put a hole here and a hole down here so that I can rip it in 3 parts. Well, easier said than done. There it goes. And here's the rough edge. And do like I did last time. Flip this over and cover the smooth side so nothing falls through. I have to poke this one more time. Yep. Or had I been thinking, I could have just ran it over all 3 holes instead of ripping it apart. Just like I'm about to do now. Boom. That was smart. I have a well in the middle, one on each side. And I'm going to take 3 rings. So I want to make sure that that well is deep enough. I'm going to put some chemicals in here, and I don't want the chemicals to escape. So I have 1. I'm bending that paper back. 2. Three. All 3 wells. So now I can trap whatever's going down in that. And this lab says, oops, where my lab said, please don't close that window next time. Let's go. Maybe a little faster. There it goes. Okay. So it says, chemistry is the study of matter, its properties, and how it reacts with the environment. This lab's about crystals, so we're going to look at something crystally apparently. And it says crystals are made of molecules or atoms that stack neatly like building blocks to form special shapes with special properties, kind of like if you were to stack dice. So some crystals come kind of square. Some come in different random shapes. It doesn't have to be a perfect cube. It can be triangular or it can be long. It can have little edges poking out all over the place. Right? So dehydration is taking the water out of something. If we start with a wet chemical, which we're going to do just the opposite, we can remove the water and the crystal should solidify and turn into a crystalline material. So if I have something that would normally be a crystal and I had water in it, I can dehydrate it. Like if I had salt water, I could leave it in a dish and let it dry out, and on the bottom I would just have plain salt, probably by the end of the week, if it was thin enough. Crystallization is the process of removing the water and letting it turn back into the crystal it wants to be. Two things we're going to look at. One's called an ionic compound, which means ions are anything that has a charge. So when you see symbols for chemistry and it says something like Na plus, just like a battery has a charge, or Cl minus has a charge. In fact, you put those two together, NaCl is table salt. So anytime you see that, those are called ions. They like to stick to each other when water's not around, but if water's around, they split. They scatter real fast. So if I take a little bit of salt and I put some water on it, it should just dissolve really fast because it splits apart. The other thing we'll look at is called a polar covalent compound, which ionic means it has a strong charge. These polars means it has a little bit of a charge, like the North Pole and South Pole, but not nearly as much. So if I put water on this and it splits really fast, what do you think is going to happen here? Probably not split really fast. In fact, it might need a little bit of help. So what we're going to do is we're going to see if salt and sugar, if we can tell the difference underneath the microscope. So let's pretend that you spilled. I did this actually several years ago. I was at a cooking dinner for St. Patrick's Day, and everybody there was making their own dish. And there was a big tub of salt, and there's also a big tub of sugar on the table. And it wasn't me, thankfully. I would have been really embarrassed, but the person that was cooking, she was making Irish soda bread, and she put her cup full of sugar in it when she was making it. And when it was done and we all tried it, we all wanted to kind of almost vomit because it was so salty. She took a big scoop of the salt, so a whole cup of salt in her bread, and it was not good at all. But let's say that you spilled salt and sugar. How do you know? How do you know which is which? I gave you kind of a clue, and that's kind of how I set the rest of these labs up. I give you a little fun idea, something science-based, and then you can figure out what it means or what you want to do with it. And of course, I'll walk you through each of them. But based on what we just talked about here, if you had the salt and the sugar, what's one way that you can figure out which is which? Well, when we're talking about dehydration and rehydrating, we're looking at water. If I put a little bit of water on each of them, which one would dissolve faster? Should be the salt, right? So one way to tell would be the salt. Another thing that you can do is when you're looking at ionic, the plus and the negative, the strong ones, they stack like blocks, just like this. You have this water solution, this mixture of salt water. You take the water out and it stacks like a building block. Polar covalents stack a little bit, but not very well at all. They break apart really easy. It's like taking all these dice and trying to get them to stay into a nice organized stack. They don't want to do it very well. So if we look under a microscope, we should see a couple things. If we add water, we should see one thing dissolve really fast. But just looking at the crystals, we should see there's a difference between sugar and salt. So your envelope should have sugar in it and salt. There it is. My tabletop's still pretty dirty. But there it is. Science is ugly. Get used to it. Sugar, salt. So I'm going to shake them down. So the sugar and salt are all the way at the end. I'm going to get my spatula. And I'm going to get a little messy. So I can either scoop out with the spatula, or I'm just going to try and do a controlled pour. On my glass. glasses on, so I hope my controlled pour is doing really well. One of the perks to having the tape on the bottom is that when the salt hits the tape, it should stay put. And you don't want to fill this well completely up. You just want to sprinkle a little on it. So you can see right through it. Right. Tap it. And that's the beautiful thing about the well, is that the well holds salt in it. Yeah, I still have quite a few salt crystals. Okay, next one. Put a little sugar in the opposite side. So I need to label these. Salt. S-A-L-T. I'm going to go all the way to the other side. The pink. I'm going to put my finger in here so I can see it. Cool. Oh, yeah, I can still see my finger through it, so I didn't go too crazy. I'll label that my sugar. And if you want to, you can put, there are other materials in there. You can put a little pepper. Yeah, what the heck? Let's put pepper in another one. Let's see if pepper looks like either of these other two. I'm totally missing it. Okay. I got a few pieces in. That's where the spatula comes into play. Just brush what I want in. Cool. Spread it out a little bit. Now it's time to investigate. Let's go to, here it is. Right. We have stage all the way down. I'm going to start with the sugar. My objective is on the red. Whoa, or scanning. I can see the light going right through, and this is even better because I know my light's in the right place. And I'm going to slowly bring it up. Maybe I'm going too slow. Here we go. Cool, there they are. Sugar crystal. What do you think? Perfect cubes? Not so much. Actually, they look kind of like a hexagon with a point on the ends. Let's see if I can find any others. Is that the way all of them are going to be? Those look like fractured hexagons with a point. That's cool. Can you see the surface? Those are, a couple of those are really cool. Pardon me, a little tickle in my throat. So if I were to draw this, which is part of the notebook idea, say I'm on low power. Ooh, let's check it out on higher power. Okay, that's pretty cool too. You can see it's like slicing right through the layers. It's actually really cool. It reminds me of an ice cube, kind of. I'm going back so I can draw what I saw. I see the one I want. Sweet. No pun intended. It's really hard to focus on that one. I get as close as I can. And then on my notebook, I would draw, what do you see? I'll flip to the screen with the notebook. So I'm at 4x and 10x. 4x down here, 4 times, 10 times up here at the ocular. So I'm looking at 40 times magnification. And I see this cool, almost like a tube. On the inside, it looks like it had bubbles on it. It's not a real tube. But they're almost cylinder shaped. And I know not perfect cylinders because I can see a sharp edge here. See another sharp edge here. So I'm sure it's more like a hexagon, well, almost like looking at the pencil, like that. But it doesn't focus. 40x. Now I want to go over and check out, we'll stop at Pepper and see what Pepper's doing in the meantime. I have to turn my slide. Lift up my spring clip. There's some Pepper. Pepper's a challenge. Probably because it's thick and the light's not going through very well at all. So let's turn on the top lighting this way, and now we can look at it a little bit better. It's almost fuzzy, but you can see the cracked or broken edges around a little bit. Here's the edge of the paper. Whoops. What is that doing there? Do you see it? That thing that looks like a dice, a die. It doesn't look very sugary. Doesn't look at all like the sugar did. So draw my pepper. Maybe I can go in a little bit closer. Flip the rotating, sorry, I keep saying rotating, revolving nose piece to one more objective. Ooh, too close. Yep, just too close. Come back out. That little cube is driving me crazy. Right, so same thing, I'm at 40x. And this first one was sugar. This one's pepper. It's that weird cube that I'm obsessed with. And it's weird, doesn't look very dark, like black pepper. Is all pepper black? This weird rock looking thing over here. So I'm curious, I have some more pepper in here. I'm just gonna dump a little bit of pepper on the table. My book, sure enough, I only see a couple black specks. The rest are white in color. So I'm pretty sure the black speck is going to be pepper. I'm labeling it. This might be white pepper, but the cube, don't know what it could be. It's not sugar. Definitely not sugar. So I'll take a stroll on over to the next. We already looked at our sugar. Oh, there's another cube. Yeah, look how perfect the cube is. It's like a pair of dice. Huh. Looks like a white pepper, piece of a white peppercorn. Cruising over, cruising over. My blue ring is around my salt. Booyah, I think is what the kids say, right? Cool. So that's salt. Just figured out what was in the other pepper container. So we have all these little cube salt crystals. Salt is pretty sweet, but not that way. Wow, I wonder if I can nudge these salt crystals to go in a row. It's a salt rave. Do, 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 do. It's a party. Pretty tough. I don't want to spend too much time doing it. But if we know how many salt crystals it takes to get across our field of view, we can actually measure the salt. So I'm trying to get it kind of close. Ooh, over pushed. Well, I'm just going to say I'm at 4D times magnification. I have one up in that top corner, one right below it, one kind of crooked below that, one big one. It's about at least twice, almost 3 times as long as the others. Weird. What's it doing in there? Maybe it's not salt. One that's kind of to the side, but if that one were nudged, it would go in and fill up that blank. I'm sure of it. And it looks like another one down at the bottom. So if I say that middle one's 3 long, it would be 1, 2, 3, 4, 5, 6, 7, 8. So about 8 salt crystals. Is it 40 times magnification total? So now I want to test that other thing. I don't know where I put my dropper. So you'll need your eyedropper. The other thing was dissolving. So I'm going to get eyedropper, glass water, blow out, bring in. Perfect. I only need 2 drops. Right. When I do this, I'm going to rest both elbows on the table. Gives me control because my feet are on the ground. Each elbow is on the table. That's 3 points of contact, so that's really good. I'm hovering a little drop of water over. Bloop. Look at it. They're breaking apart already. We'll see the big one in the middle, see it dissolving. It's almost like it's ice in a hot water bath. There it goes. So we could build a really cool experiment and time how long it takes to do this. Is that some kind of weird creature growing there? We unleashed it from the salt. Okay. I don't think I'm going to get anything with pepper. So I'm just going to go straight across. Get sugar under there. Oh, yeah. This sugar's going down. Ooh, that's a pretty sugar crystal. It's like rock candy. Boom. I still have some water in my dropper. I'm going to lean on the table so I have control. Hover 1 drop over it. Coming in for the kill. Boop. I don't know. That looks like it's dissolving kind of fast too. taking longer, I think. Makes it to really experiment with that though. Just like ice cubes. I'll take a Sprite Moneypenny with ice cubes in it. Real slow. Actually, I think we kind of hit the stopping point. So it'd be interesting to look up why it would stop melting. Why would it melt at the beginning and then stop all of a sudden? Maybe you could Google that. At what point does sugar stop dissolving in water? That might give you the answer. Is it changing? Maybe a little bit. But we actually watched nonstop the salt go. So, salt, was it ionic or is it polar covalent? Its shape, it was perfect little cubes, right? Which is what the ionic is. Ions like to split apart fast in water. The salt definitely split apart fast in water, so it's totally an ionic compound. The polar covalent still has weird shapes. It's not perfectly cubed anywhere. It's taking forever to break down. So that's polar. It doesn't like to split apart in water as much as salt does. Do you ever put too much sugar in like a drink and all the sugar that sits on the bottom? The only way to get that broken up is to heat it up, get it boiling. All right, and then that's all for the 101 section. With the 102, 101 is kind of like playing with things, not doing so many slides, but just playing with things. 102 is working more with the slides, learning how to build a slide, how to stain a slide, how to maneuver with the slide a little bit better, looking at things in 3D, looking at things with the scanning upper light, looking at things from below. Let's take a peek at this from below too. There's a special filter that I wish I will show you anyway. There's a special filter that looks like a pair of glasses. Oh, I won't be able to. Sorry, I have the slide on it. Nuts. But this is a polarizing lens, so it only lets light move in one special way. Maybe if I take two of them. One thing I can count on is that sugar is not melting fast. So if I take one pair of the glasses and put it under the specimen with the light coming up through it, I take the other pair of specimens. You'll just have to wait to do this because you only have one pair of glasses. And put over it, oops, polarizing light. I'll have to adjust the bottom one. Oops. Oh no, I moved it out of the crystal. Hold on, let me find it again. Paper. Oh no, I lost my good one. That's okay, these will have to work. So there are some sugar crystals. Just slide this one in like I was talking about. Hold it right here. So it polarizes the light, which means all the random light waves, which we'll talk about later, go in different directions. If I turn this, can you see the colors coming out? Things that are transparent refract light, but they usually don't refract light perfectly. So they actually are holding the ability to work like prisms. Let's put the color up. Ooh, that was a good one. I just missed it. There it was. And sugar is a really good example of that. Sweet. I think I'm saying sweet too many times. Mm-hmm. Cool. So you take a break. I'll stop this recording. You can watch it later if you want to add on, and then we'll start 102 in just a few minutes. Oops, I don't want to end.